Morning students. After lunch break, we'll see physics class in that small topics that is very important for you in 5 mark question in university examinations. Today class is about photoelectric effect. Usually we know that the X-ray photon when interact with the atom, in that atom the electron revolves around the atom, it will eject out from the atom. This will produce a light that is called as photoelectric effect. Here it will produce ionization. So there are three main principles which involves in ionization. In that, photoelectric effect is one of the method or one of the mechanism in ionization. We'll see little detail about photoelectric effect. Now, there are three main principal mechanism that involves in ionization. The first one is photoelectric effect, and number two Compton effect, and number three pair production. These three are very important for you in university examination. They will ask you in 5 mark question. In sometimes you may get these questions in 3 mark. Now, first we'll see about photoelectric effect. Already you know that in photoelectric effect, a photon having an energy E that collides with an atom. See, these are the atom and the electron revolving the atom, that collides with the atom and ejects one electron from the case shell. Okay, this ejected electron is called as photoelectron and it has a kinetic energy E. That means which is equal to the binding energy of electron in the case shell. So what do you mean by binding energy? The electron that revolving around the nucleus in different shells, K, L and M shells. Here if the electron is having here, there is a binding energy, is the bond between the nucleus and the electron in the orbit. So here binding energy is more. In K shell, L shell, the binding energy is little less. But in case of photoelectric effect, only it happens only in the very close shell, that means K shell electron. If this electron, see the fast moving photon interact over here, fast moving photon having an energy is equal to h nu that interact with the electron in the K shell, this electron is ejects out. This electron is called as what? Photoelectron. Now there is a vacancy over here. This vacancy should be filled by the L and M shell. Okay, what happens if the electron from the L shell or M shell that will occupy to your empty space? Here it will produce X-rays, that is called as characteristic X-rays. The vacancy that is filled here, it will produce an X-rays. That X-ray is called as characteristic X-rays. Okay, usually this photoelectric effect is only happen in the tightly bound electron, that is K shell electron. Now, this photoelectric effect here, the probability of photoelectric cross section per unit mass is proportional to Z cube by E cube. What do you mean by Z? Z is the atomic number of an atom. What we are using here, say for example, for a photoelectric effect, we are using as iodine or barium atom, that atomic number, and it is also involved in the energy, incident photon energy. See here, as this X-ray photon energy increases, if E increases, the subject contrast will decrease. That we'll see in the next graph. See, if X-ray photon energy is increased, the subject contrast decrease. As the atomic number increases, the subject contrast is also increase. Suppose you need to increase the photoelectric effect. Photoelectric effect na light produce பண்ற அந்த atom உடைய capacity increase பண்ணோம் அப்படின்னு பார்த்தீங்கன்னா higher atomic number இருக்கிற இதுவை increase பண்ணீங்க அப்படின்னு சொன்னீங்கன்னா ஆட்டோமேட்டிக்கா இந்த subject contrast increase ஆகும். பட் யூசுவலா என்ன ஆகும்? photo energy increase ஆச்சுன்னா subject contrast decrease ஆகும். So அதை avoid பண்றதுக்காக we should use a higher atomic number to increase the subject contrast. That's why we always use this barium and iodine as a contrast agent. Already we know that நீங்க quality control படிச்சிருப்பீங்க barium swallowing அப்படின்ற ஒரு இது. So barium and iodine that will interact in your body, protein ஓட interact ஆயிட்டு there it will absorb the X-ray photon. Here it will produce luminescence, photoelectric effect. Okay, now this is the graph. It shows a relationship between the photo energy and photoelectric effect. ஓகேங்களா, இந்த photo energy-க்கும் and photoelectric effect-க்கும் if the photo energy, photoelectron energy increase ஆயிட்டே இருக்கு அப்படின்னு சொன்னோம்னா what it happens, your absorption, photoelectric effect slower decrease ஆயிட்டே வரும். But this absorption of photo energy may increase, but in some exception case la it may increase. See here usually பாத்தீங்கன்னா இந்த particular point பாத்தீங்கன்னா photo electron ஓட energy வந்து ஸ்லோவா இப்போ 40 kilo electron ஒரு 80 அப்படின்னு increase பண்ணும்போது 0 1 2 3 increase பண்ணும்போது என்ன ஆகுனா the photoelectric effect ஸ்லோவா குறைய ஆரம்பிச்சிருக்கும். So அப்படிதான் first last paragraph பார்த்தோம் இல்லையா. So higher atomic number வந்து பேரியம் அயோடின் அப்படின்னு யூஸ் பண்ணோம்னா photo energy increase பண்ணோம்னா இங்க absorption இந்த லெவல்ல இருந்து இங்க increase ஆகுது. 1 ல இருந்து 6 times அதுக்கு மேல atomic number பொறுத்து it will also increase. இது வரைக்கும் increase ஆயிருக்கு. Suppose if we are increasing a photo energy slowly, your absorption will also increase. That means photoelectric also will decrease. I'm sorry, the photo energy also decreases, but there are some exception. Here it will increase in particular condition. This will increase, that is called as kh அப்படின்னு சொல்லுவாங்க. ஓகேங்களா. See, the absorption of photon increase markedly as the incident photon energy increases from below to above the binding energy of K shell. So below length to the above binding energy of K shell. Binding energy oda அதிகமா இருக்கும்போது increase ஆகுது. Again photon energy increase பண்ணிட்டே போறீங்க. Photoelectric effect, photon energy increase பண்ணீங்கன்னா photoelectric effect குறைஞ்சிட்டே போகுது. This line is for iodine and this line is for barium. Barium oda atomic number is maximum than iodine. So little that absorption capacity, photoelectric effect is maximum over here. This exhibits a sharp discontinuity is called as absorption edge. This edge is called as absorption edge. For example, if the binding energy of K shell of iodine is 32 na inge vechukonga. Binding energy of iodine is 32, though in the இடத்துல இருக்கு iodine, correct? Yes, which have 6 times absorption. higher இதை விட ஒரு 6 times increase ஆகுது. See here, இங்க விட ஒரு 6 times and absorption edge அப்படின்றது increase ஆகுது. These are the some exceptional case. Okay, now listen carefully. The photon energy corresponds to the absorption edge increases with atomic number. So atomic number increase பண்றோம்னா the photon energy automatically increase ஆகுது. The absorption of an element like hydrogen, carbon, nitrogen and oxygen present in our soft tissues. Soft tissue அப்படின்னும்போது எல்லாமே organic molecules தான் இருக்கும். Carbon, nitrogen and oxygen இது மாதிரி தான் present ஆயிருக்கும். அதனுடைய energy எவ்வளவு இருக்குன்னு பாத்தீங்கன்னா below, see here is below 1 kilo electron volt. அதை விட energy கம்மியா இருக்கும். So the iodine and barium and even a lead also use that absorption is 33.2 or 37.2. 33 or 37. See, this is 33. In the curve பாத்தீங்கன்னா this is 33. I will show you over here. See, this is 33 and next in the dotted line irukya, this is 37. So 33 and 37 இருக்கும். And suppose in case of if you are using lead பாத்தீங்கன்னா 88 absorption இந்த இடத்துல வந்துரும். இது 80, so 88 இந்த இடத்துல வரும். அந்த peak இந்த இடத்துல இருந்து இப்படி peak produce ஆக ஆரம்பிக்கும். Am I clear? Okay, so this is very important. The photoelectric effect is very important in soft tissue imaging for photo energy. ஓகேங்களா. So that's why we are using this iodine or even barium or even sometimes lead that has been used for photoelectric effect. Up to this photoelectric effect is over. Hope you understand. Any doubt, please contact me. Thank you.